So we're going to talk first about the slope and then the different forms. We have point slope, slope intercept, general form, x and y intercept form. There's also sorts of kinds of lines we can draw. Talk about horizontal and vertical lines, parallel and perpendicular lines. Okay, so here we go. So the slope. The slope we have learned for over and over and over again is rise over run. It is the vertical change over the horizontal change. It's y2 minus y1 over x2 minus x1. That's the actual formula for slope. Okay? Understand. Sometimes, you see this little delta? They'll show the equation or the formula. It's delta y over delta x. That means the change in the y over the change in the x. Okay? And I know they have the formula y2 minus y1 over x2 minus x1, and there's a time and place to use that, and that's great. If you want to use it, fine. We're going to talk more. When I do the slope, I'm just going to do it. I'm just going to write it down. So understand what slope means. It means the change in the y, how did the y change, over how did the x change. Okay? If you're going to use that formula, it doesn't matter which point you start with, but it matters that you're consistent. If you start with the second point up top, it's got to be the second point on the bottom you start with. Okay? So, what do I mean by the shortcut? Let's do the first one with the formula. So, the second y minus the first y over the second x minus the first x. So, it's not hard. You can write the formula down quick and easy. Right? Now, let's think about what slope actually means. How did the y change over how did the x change? So in this second one, how did the y change? How did that height change? Up or down by 8? When I went from a 7 to a -1. And it depends on which point you start with. I always go from left to right, but if you go the other way. So I went down 8. And how did my x value change? Was it a positive or a negative change? Positive 2. So the slope is -4. Okay? That's what slope actually means. What's the y change over what is the x change from point to point? So try this one. What is the y change over what is the x change? How'd that y change? -4. And how'd the x change? Okay, they're both -4s. So that becomes a 1. All right. We all know that this is a positive line, yes? This is a negative slope, right? Okay. So you got to be able to find slope of a line. We can do that. Slope intercept form. Guys, I know you have this. This should be like a tattoo on you somewhere. Y equals mx plus b. M is the slope, b is the y-intercept. We know this, right? Slope or point slope form. You may know it, you may not know it. Depends on how your teacher taught it last year. Y minus the y in the point that you're given equals the slope times x minus the x in the point that you're given. So if you have a point and a slope, this is how I'm going to write the equation of a line. And if I want to put it in slope-intercept form, I'm just going to distribute and add the y1. Okay. Good. You see that? But this form might be unfamiliar to some of you. All right, let's see if we can write an equation. So, we want the equations in slope-intercept form. So in the first example, I have a y-intercept and I have a slope. So I'm pretty much done, aren't I? I can just write the equation. All right, this is my slope-intercept form. I have everything I need. There's no real work there. The second one, I have a point and a slope. So I'm going to use point slope form. Now we start by writing the generic form of the line and then filling in. So it's y minus a negative 3 equals the slope, negative 2/3, times x minus a negative 2. So that's in point slope form. So if that's what they told you to write it, we'd be done. But they want it in slope intercept form. So I'm just going to take and simplify this. We're going to distribute. And our very last step is just to subtract this 3 over. So I take this 3 and I subtract it over here. Okay. Now, if I'm subtracting 3, I'm actually subtracting 9 over 3. We have to get a common denominator here. If you got lost in the fraction step. Okay. Is that good? So the next example, they give you 2 points. So for every line, we have to have what before we can write our line? The slope. What is the slope here? How did the y change? 10 up, positive 10. And how did the x change? Positive 2. Good. So our slope is 5. Okay. Now we live in America, so we have choices. Which point do you want to use? Doesn't matter. You're going to get the same answer regardless of which point. So let's just use the first one. So y minus, go ahead and write an equation here. And again, some of you might have learned how to write an equation using slope-intercept form, and you're finding the b. And if you do that, that's fine. If you like to do it that way. You'll get the same answer regardless. Okay. So far, so good? Okay. How about a line with an x-intercept of negative 3 and a y-intercept of 4? How can I find the slope there? Isn't the x-intercept of negative 3, isn't that a point? Can't we write that as a point? So if it's an x-intercept, the y part is 3. And if it's a y-intercept, the x part, the y part is 0. If it's a y-intercept, the x part is going to be 0. So those are our 2 points written in point form. What's our slope? Four over 3. Good. And they already gave me the y-intercept. This is my b. I'm done. Okay. Easy enough. Okay. All right. So for linear equations, you're describing something changing at a constant rate plus a starting point. So if I am renting a car, and it's $30 to rent the car and 25 cents per mile, how would you write that as an equation? What's the thing that's changing our cost? The miles, right? So that's going to be our x. This is your m. Your starting amount, let's not worry about per day. These are just one daily rentals. So the cost of the car is 25 cents a mile plus $30. Right? That's it. How much does it cost to rent a car for 1 day covering 60 miles? So we're just going to plug that 60 in for M, number of miles. $45. And if they give you the total rental cost, you're going to plug that in for C. And you're going to solve that to figure out how many miles. Right? We've done all these before. And you get 71 miles there. Okay. So that was a pretty quick equation to write. Because they essentially gave you the slope and the y-intercept. Okay? We good? All right. The number of female prisoners in Florida's prisons rose from 2,425 in 2000 to 4,026 in 2006. Find a linear equation relating the number of y of prisoners in the year t. Make t equal 0. Be very careful in Math Excel, because I always like to use x's and y's. They'll tell you to use a t and you'll have it all right, but you're using an x and you're going to count it wrong. And you'll be like, what? Okay? All right. So how are we going to do this?
I'm slow of 2.
The two things. Can we write the two things as points?
Yeah.
Yeah. Okay. So they're telling you to make 2000 a 0. That means 2006 is a 6. So if I wanted to write this as a point, at year 0, my population is 2,425, and at year 6, my population was 4,026. Now, how do I know the time is my x and population is my y? What do you think is changing per something? Does that make sense? The population depends on the year you pick. So the population is your dependent variable. That's going to be your y. Right? So, what's our slope? It's an ugly fraction, and that's okay. Something like 1,601 is how the population changed over the 6 years. Okay. And can I just write my equation now? Do I have a y-intercept? Was I given a y-intercept? I was given a point here that time is 0, so that's the y-intercept, so I can just write my equation. Because we're starting the problem at year 2000. So that's our starting population. And then it's changing. How many prison or women prisoners were in 2003? So I would plug in what? For what? 3 for x, and oh my goodness, we're supposed to make sure it's t. I never use t's because they look like plus signs. All right, so we're going to plug in a 3, not 2003. Keep in mind, you change that. Remember to round, you can't have part of a person. So round it to the nearest whole person. Okay. Easy enough? You know how to plug and chug into an equation? I'm saying easy enough, but if you have questions, please ask me. It's been a long summer. You guys haven't done any kind of math. Okay. Zero and undefined slope. If I have a horizontal line, I am rising none. There's no change in my height, but the change in the x can go up to infinity. So you can take 0, let's just make that any number, divided by any number, and I get 0. So horizontal lines have a slope of 0. Vertical lines, on the other hand, I'm rising a specific amount, but I'm not running at all. My horizontal change is 0. You cannot divide by 0. So that makes an undefined slope. These are the easiest equations to write. If it's horizontal, you write the equation to describe how it's hitting the y-axis. It's hitting at a specific k value. Whatever the y value is there is going to be your line. Y equals whatever that number is. If it's vertical, you are cutting the x-axis at a particular number. So it's x equals whatever that number is. Okay, this is the most often things people get twisted around, because they think horizontal lines, that looks the same as the way the x-axis is going, so it would be x equals. What axis is it cutting? It's cutting across the y-axis. So it's y equals. Even the x-axis line is x equals 0. I'm sorry, y equals 0. Trying to prove a point I'm writing wrong. That's the equation of the x-axis. So it's flipped to what you think, okay? So easy breezy ones to write. So we want a line passing through these points. What's the slope between those 2 points? What's the slope? What's the y change? 0 over 4. What kind of line do we have here? What kind of line? Horizontal, right? So it's going to be y equals, what does the y equal in both points? 3. Every single point on that line is going to have a y of 3. Okay? Next one, they're telling you you have a vertical line. Vertical lines tell me it's x equals. And what does the x equal? In that point, 5. That's it. If they told you it was a horizontal line through that point, you would say y equals 7. Okay? We good? All right. General form. So this is another form of the equation. Ax plus by plus c equals 0. A, b, and c should be integers, so you should not have no decimals or fractions in a general form. A and b, one of them can be missing, but one of them has to be there. You have to have at least an x or a y for it to be a line. Okay. So a, b, and c are integers. Both a and b are not 0. Some books a has to be positive. Okay. Some books the c is on the right side, so it just all depends on the author of your textbook. Okay. We want to find the slope of this line. We do not want to have to rewrite it in y equals form. It's a lot of work. But mentally, let's just do it in general here, so we never have to do it again. If I were going to get the y by itself, what's the first thing I have to do? I got to move the a and the c over, right? And then what would you have to do? divide by b. So, what's my slope? Negative a over b. So the slope of a line in general form is negative a over b every single time. So we don't have to redo that every time. We just need to be able to say, hey, what's my a, what's my b? So what's the slope of this line? Negative 3 over 4. The opposite of that a coefficient over the b. Okay. The x and y intercepts we're going to find just like we did before. So if I'm looking for the y-intercept, I'm going to rewrite the equation without an x. My x went to 0. So if I solve that, I get y equals 6. Same thing, if I'm looking for my x-intercept, I'm going to rewrite my x for my equation without the y. And solve. Now, another form of the equation, they really don't cover too much in this chapter. It's in there, but it's not, I don't know if it's really highlighted or not. Rewrite the equation with the c on the right side, and then we want this side to be a 1. So I'm going to divide everything by 24. So here I get x over 8 plus y over 6 equals 1. We want the right side to be a 1. This is considered the x-intercept, y-intercept form. Because the number under the x is going to be your x-intercept, the number under the y is going to be your y-intercept. Right? Okay. So that's a form literally I've never seen until I looked at this book. Not used very much. But you could find your x and y intercepts all at once if you wanted to do it that way. Okay? Easy enough. All right. Parallel lines and perpendicular lines. Parallel lines are tilted the same, so they're going to have the same slope. They're equivalent. Perpendicular lines have opposite reciprocals. Opposite reciprocals. Notice 2 over 1 and negative 1 over 2. Okay? If you multiply perpendicular slopes, you should get negative 1 because they're opposite reciprocals. All right? So find a line in a slope-intercept form that goes through negative 2, 5 and is parallel to the line containing those 2 points. So the first thing you have to do is figure out the slope. What's the slope between those 2 points? 4/3. Okay, good. And what is the parallel slope to that? 4/3. And then you're going to write the line with that point. So the same steps. All they're adding is parallel part there. Okay. We're okay. All right. Next example says find a line in slope-intercept form that goes through 3, -4, and is perpendicular to this linear equation here. So again, first thing you have to do is figure out what is the slope of what they're giving you, the situation they're giving you. What's our little shortcut? -a over b, yes? Opposite of the a over the b. What is the perpendicular slope? 5/4, positive, right? And then you're going to use that to write the equation with the point. Okay. Okay, think about the next one. See if you can figure it out. There's literally no work to this. You can do work, but you don't have to do work. Just think about it. What kind of line are we going parallel to? Horizontal line, right? So this is horizontal. Any line parallel to it is also horizontal. So I know the equation is y equals. What y point are they having to go through? 7. Right? You can go through and say, the slope of any parallel line is 0, and then use the 0 with that equation, but that's what you're going to get, yeah? Yeah. All right. We're done for the day. We'll finish up tomorrow. We've got 2 slides using the calculator to do the regression. Okay, in this next one, we are finding a linear regression using your calculator. So you have a table of values, and you can always find a linear regression just by picking a couple of points off the table, but we are going to find the line of best fit. So this is the best one. You're going to go to Stat, Edit, and you might already have things in there, so you want to go ahead and clear those. Remember to hit clear and not delete. If you delete, your whole column is going to be gone. We are going to put the time in years after 2000, so our numbers are not quite so big in our equation. If you just leave it as 2006 and so on, you're still going to be okay. It's still going to be a linear regression. It's just going to have bigger numbers to write. It will still predict the same. Your equation is just going to have big numbers. So you get them all put in there, then go back at the stat, and we're going to calculate. The line of regression is number 4. Just make sure it says L1, L2, like you did with your table, and that's the equation. Okay, so when we write the equation, they're giving you the setup right here. So y equals the a times x plus your b. And I rounded to the nearest hundredth. Math Excel will tell you to round to a certain spot. If you wanted to draw a scatter plot of the points, you can see it on the left, and then the line of regression, which is the equation we drew, or we made going through with the red line. And then I'll let you go ahead and do this example by yourself. You're going to get the model, and then you can do some predictions with it, estimate with it, finding the independent or the dependent variable depending.